Hi, I'm Tomer Nahomi from Dell EMC. In this demonstration, I'm going to show you a quick overview of Dell EMC PowerStore X model and AppsON. PowerStore X models make up one of the two models types for PowerStore. PowerStore X model appliances are built on the 2U, 2-node PowerStore platform. Built with a microservices and container-based architecture, the PowerStore operating system is designed to take a full advantage of the cutting-edge technology of the underlying platform. PowerStore X models have a native hypervisor layer, which passes through the underlying hardware components directly to a virtualized instance of the PowerStore operating system. This capability allows the system to provide optimal storage performance and low latency while supporting customer applications running directly on the hypervisor. Due to the embedded VMware E6i hypervisor on PowerStore X model appliances, these nodes can be managed and monitored in vCenter along with other E6i hosts. By navigating to the vSphere client, we can see that the two PowerStore controller VMs are running on the E6i hosts of the PowerStore X model. These VMs provide the active-active redundant capabilities that are standard across all models. The controller VMs run the PowerStore operating system, and each physical PowerStore node contains one ESXi host and one controller VM by default. To ensure proper resource availability for the PowerStore operating system, the controller VMs has 50% of the node CPU and memory that is reserved by the ESXi host itself. The remaining 50% of the node resources is used by the user VMs. These VMs are protected with HA, high availability by default, and the PowerStore controller VMs are also redundant. By navigating to the PowerStore Storage Containers tab, you can find the default storage container, which is created during the PowerStore installation. Unlike traditional LAN-based vSphere storage, the Vivol functionality does not require pre-configured volumes on the storage side. Instead, Vivols uses a storage container, which is a pool of raw storage capacity or storage capability that a storage system can provide to Vivols. As you can see, a Windows 2016 VM is running on this default Vivol data store. This VM has one operating system disk and 4 data disks. The VM is running Splunk, a software platform to search, analyze, and visualize machine-generated data. Running this application as a virtual machine directly on PowerStore X is ideal for data-intensive applications that require low latency and extremely high performance. With Vivol-based VMs, there is no file system, but VMware makes the structure appear to be the same as the conventional VM. What occurs internally is quite different. Now let's take a look at it from the array side. The Vivol architecture not only gives VMware insight to the PowerStore array, but also it gives the PowerStore array into VMware. As you can see, under the Vivols tab, we can see the different disks depends on the type of the data that is being stored. Data disk, stored data such as VMDK files, snapshots, full clones, and fast clones. At least one data Vivol is required per VM to store its hard disks. Config stores standard VM configuration such as VMDK files, logs, and NVRAM. At least one config file is required per VM to store its VMX configuration file. Swap stores the copy of the VM memory pages when the VM is powered on. Swap Vivols are automatically created and deleted when VMs are powered on and off. The swap Vivol size matches the VM memory size. By navigating to the Virtual Machines tab, we can see useful information about the virtual machines and their storage metrics. The integration of the PowerStore container-based architecture with the onboard VMware ESXi host results in a new level of consolidation for enterprise storage. This ability combines the benefits of a local on-array application environment with unmatched integration with the vSphere management environment and server resources. This integration allows users to bring applications closer to storage by running applications as virtual machines running directly on PowerStore. Benefits of the AppsON capability include a new level of agility for application deployments. This feature enables seamless movement between the PowerStore appliances and VMware ESXi server, and the ability to shrink the stack by eliminating server and networking footprint for space-efficient edge and remote deployments. AppsON is ideal for data-intensive applications that require low latency or a storage-heavy imbalance of compute and storage. PowerStore X models have a vSphere distributed switch, multiple port groups, and NIC teaming that is configured automatically as part of the initial configuration process. The DVS has a naming convention of DVS minus the cluster name. The DVS has the following port groups created by default: PG-MGMT, PowerStore Management, PG-MGMT ESXi, the ESXi Management, PG Storage Init 1 and 2, VM kernel adapters for iSCSI connectivity from ESXi hosts to the controller VM, PG Storage TGT 1 to 4, iSCSI targets on the controller VMs for internal and external connectivity, and PG vMotion 1, vMotion network used for VM mobility. In addition to the default vVol storage container, PowerStore X model can provision volumes and volume groups to external hosts. For example, you can provision volumes to external ESXi hosts for VMFS data stores and raw disk mapping, RDMs, while the internal nodes have access to the storage through the storage container, which is configured and mounted by default. More storage containers can be created if needed. Now, let's clone our virtual machine to the same vVol data store. Here, I'm providing a name to the new virtual machine, selecting my PowerStore X cluster, which is where the storage controller VMs are running, and then selecting the default vVol data store. When virtual machines are stored on a vVol container, anytime a virtual machine is cloned onto the same vVol container, the system will use the VASA API called clone virtual volume and offload the entire cloning operation to the array. We can see that the cloning operation completed really quick, and by navigating to the PowerStore UI and clicking on the vVols tab, we can see that our VMware clones are actually clones at the storage array level. This makes VMware cloning instantaneous and efficient, while these clones are also globally data reduced and metadata based. I hope you will find this demo useful, and thank you very much for watching.